In this recording, we're going to learn about average rate of change. So this is kind of a simple concept in one way, and also a tremendously important concept in another way that you will use all the way up through calculus. And I'm going to have you begin by doing this warm-up, questions 1, 2, and 3. So just read the directions, get as far as you can, having paused the recording, and then play when you're ready to check your answers. Okay, so hopefully you paused, and if you didn't, please do that now. We want to look first for what's going on in each function. So just looking for patterns. Maybe it's hard to see what's going on here, but I kind of see it looks like it's doubling here, right? Times 2. Well, times 2, that's clearly a times 2. All right, so I see a doubling pattern here. Well, okay, that means it's exponential base of 2, right? So I know I can do this. But what's my initial amount? 1.55, right? The amount when x equals 0. So there's our exponential function. Let's look at the pattern over here. Well, 11, 9, it seems like it's subtracting 2 each time, right? So that indicates we have a linear. Should write over here exponential. And let's see, if it's subtracting 2 each time, that's our slope, right? So we're talking about y equals mx plus b, so minus 2x. But what's the starting amount? Well, just like the starting amount over here with the exponential is when x equals 0, similarly, the y value when x equals 0 is 11, so plus 11. How about number 3? Which represents a linear function? We have to look at each one and see what the behavior is. If this is linear, then I'm adding the same amount each time, like plus 3. Well, it doesn't keep adding plus 3. It's a times 2, so not linear. This one goes minus 5. And then it continues minus 5. Okay, so that has some definite potential. This one is a plus 1, plus 2, plus 3. That's not linear. Okay, so it has to be this one. Constant rate of change. Let's write that in here. And a fancy mathy word for a constant rate of change is a slope, right? The rate of change is the slope. So the slope formula, we use m for slope, was y2 minus y1, the difference in y's, well, the rise, right? Let's just write that over here. Rise over run. Change, the change between the y values. How much the y values changed is the rise. The run is how much the x values changed. We have to go in a specific order. It doesn't really matter which one we decide is the first or the second point, but we have to go in the same order consistently. Okay, so let's find the rate of change. Another word for that is slope, right? For these linear functions. It's a little hard to see, it's kind of small, but I can tell you what some of these points are. That point right here, I'm going to just make it bigger, is 1, 5. And this point here is 0, 3. All right. So just looking at it, right, we said rise, that's 1, 2, it rises. 1, it runs. It's obviously a positive slope, right? So we can just say the slope is 2. Let's just kind of write that over on the side here. We know it's going to be a 2 over a 1. But we can also use our formula here, right? We can and say, okay, in terms of utilizing a formula, we've got the change in y values, the y2 minus the y1. Let's label everything. That's going to help. Each point has an x and a y. Which one's the second point? Which one's the first? I typically do the point that's to the right more or up more as the second point. It's going to have bigger y values. It's always easier to subtract and end up with a positive number when we subtract. So like easier to do 5 minus 3, right, than 3 minus 5. So I need to establish what my second point is and be consistent though. So I've got 5 minus 3 divided by 1 minus 0. So that's going to be a 2 over a 1. Isn't that what we said the slope was going to be? It's 2. All right, for our second example, I want you to pick any 2 points, use your slope formula, and play the recording and check your answer. Okay, so hopefully you'd pick 2 points. I'm kind of simple, so I'm just going to pick these first 2 points. All right, you might have said, well, I'm going to pick 2 points that don't have any negatives. Good choice, right? That's also a good choice. So let's see here. Call this my x. This is like my first point and my second point. So y2 is 9 minus y1, which is 13. x2 is negative 5 minus, I have to be careful here, minus negative 10. All right, but you recall that subtraction of a negative we can make into addition of opposites. So plus plus. So it's really like negative 5 plus 10, which is really a 5, right? And the numerator is negative 4. We should have expected to see a negative slope, right? Because as the x's increase, the y's decrease. So we know we're talking about a line that goes down like that. Finally, the last one we don't need to do a whole lot of work. What's our slope? There it is, right? In terms of y equals mx plus b. So if it's already written as an equation, not a graph or table representation, we can just say what the slope is. 2/3. Our next example gets into some exponential functions. Clearly, the rate of change, the slope right here, is very flat. Whereas later on, as the x's are bigger, the slope is not very flat, it's much steeper. So we don't have a constant rate of change. The question asks us here, calculate the rates of change between each of the consecutive points in the table. So we know our x values are going up by 1. Let's look at what's happening to our y's. So that's a plus 3, plus 6, plus 12. So not constant. Let's find the average of those rates of change. So remember how to find an average, right? You add them up, divide by how many you have. So we're going to add up 3 and 6 and 12 and divide by how many we have, which was 3. All right, do some mental math. Come up with an answer, please. All right, so however you figured it, hopefully you came up with 21 over 3, which evaluates to be a 7. That's our average rate of change. Okay, well, let's find the slope between points 2, 3, and 5, 24. In other words, this is my point 2, this is my point 1. So when I talk about slope, I'm talking about y2 minus y1. Okay, I'm talking about 24 minus 3. All over x2, which is 5, minus x1, which is 2. Okay, so we've got 21 up top, 3 on the bottom. That's starting to sound like something I just did, right? Of course, because average rate of change is slope. That's what we mean. The average of the rates of change works out to be the slope, the line that would go between those 2 points. Okay? Now the second part here is going to be, let me see if I can, well, you can see the numbers. You can kind of flip back and forth. It says, find the average rate of change over the interval 0 to 3 in the graph. So let's identify those points. When x is 0, y is 1. So we have this point 0, 1 right here. And then 3. When x is 3, y is 8. So I'm talking about between 3, 8, and 0, 1. Let's label everything. So I'm speaking about between 3, 8, and 0, 1. Okay. So can you take time to find the average rate of change between these two x values, the slope? When we see average rate of change, you can just think slope. Play the recording when you're ready. All right, so hopefully you took time and did that. So the slope here is 7/3. Let's see if it really is. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Yep, up 7 over 3. We could have found that by graph. Now let's find the average rate of change for a different function over the interval 1 through 5 in the x's for this function. Sounds pretty complicated. Let's make it easier. Basically, guys, we just need to find the two x values and two y values. All right, so I need to find these 2 points. They each have an x and a y. Think if you know what the two x values are that we're going to use, and write those in if you know them. So hopefully you realized, hey, we're using the x values in this interval. So like 0 was the first x value, 3 was the second x value in the example above. So we're talking about 1 to 5, right? The y values, well, in the graph example, we could look right in the graph to find the y values. But if we're not giving a graph representation, we're given a function form representation, I should say an equation form, I can find out what is f of 1. That's going to tell me the y value when x is 1. So let's do that work. Okay, that's not hard. 3 to the 1 is 3, times 2 is 6. That tells me the y value when x is 1 is 6. Now I need to find the y value when x is 5. Well, I don't know 3 to the 5th. So I can get out my calculator, I can find out that value, multiply it by 2. It turns out to be 486. All right, that's the y value over here. Turns out I need more space for it. All right, I need you to take it from there. Find us that average rate of change, that slope, right? Play the recording when you're ready. All right, hopefully you paused. All right, we call this x1, y1, x2, y2. So change in y, right? This our rise. 486 minus 6. Great. Mental math right there. We know that's 480. 5 minus 1. Another mental math. We know that's a 4. 480 divided by 4. You might say, I don't know. Well, that 0 is not going to factor into the division. We just know we're going to have a 0 in the answer. But 4 divided by 4 is 1. And 8 divided by 4 is 2. So we're looking at 120. That's our average rate of change for this function. It's really steep slope. All right, so let's summarize what we've done. So the average rate of change, AROC, equals the change in y. That's a Greek letter, that triangle I drew, over the change in x. That's a Greek letter called delta, and it means change. Change in y divided by change in x. So how do we find the change? Well, like change in temperature. Today was hot. This weekend was cold. All right, well, subtract, right? That's how you find change. So we do y2 minus y1 divided by x2 minus x1. How's that compare to the slope formula? They're the same, right? Slope, as we've been saying all along, average rate of change, same concept, different names. Thanks for watching.